Hey, Bogdanovsky here with another video. Quadratic functions made easy just for you. And in this video, a standard equation of that quadratic function. So let's start with sort of clarifying what this quadratic function in standard equation looks like. So most of you familiar with ax squared plus bx plus c notation, y equals. Often used in textbooks, in your classroom environment. You're also going to see notation f of x as a function notation where ax squared plus bx plus c also follows. So this is the second degree function. Coefficient a is not equal to 0. And the value of a directs the opening of the parabola. At this point, you may be familiar about that. The coefficient b, the second coefficient in order, is related to the location of axis of symmetry, and the constant c value typically represents the y-intercept. So there is a bigger context for a quadratic equation because it is a subset of big family of polynomial functions, where if you're familiar with this notation, that's fine. If not, this is just a quick overview that typically polynomial functions description comes with letter p with one variable x, and then you have this notation where you have coefficient a with subscript n, and x is to the power of n. Then it's followed by the lower value. So this is a with subscript n minus 1, and the coefficient shows n minus 1. So you see sort of the descending order all the way down to a term with variable x to the power of 1, which is followed by the constant, because that would be x to the power of 0, kind of, if you make that analogy. So the last term is a0. But in the high school courses, most of the time, this is not utilized. We don't see a2x squared plus a1x to the power of 1, because that would be maybe confusing to students. So typically, traditionally, you will see that notation, as we already introduced, ax squared plus bx plus c. And also you could see, when talking about greater family of functions, polynomial functions or other functions, f of x notation also is introduced. Now, to generate a quadratic function, we can start typically with set of values. Let's say we have some data, and then we use the finite differences to determine if the behavior of those points follows the quadratic function formula. Okay, so pretend that we don't see y is equal to x squared. But let's say we just have the data of points. So x ranges from -3 to +3, and the y values are from 9 down to 0 all the way to 9. And then we do the first differences. So this is the column where you find the values between two consecutive values of y. So you start with the second minus the first entry. So 4 minus 9 is equal to -5. Then you would go 1 minus 4 is equal to -3, and then 0 minus 1, and so forth. And then finally, the last difference will be 9 minus 4 is equal to 5. So you see that the first differences are not constant, but there is a pattern here. They do increase by value of 2. And then you do the second column of differences using the first differences as the y values from the previous first differences method. So -3 minus -5, you get 2. -1 minus -3, you also get 2, and so forth. So you start observing that the second differences are constant, and based on the pattern, this function would represents quadratic function because the second differences are constant. So how do you find the leading coefficient? It is the second difference values, which is 2, divided by 2 factorial. Factorial notation is a product of natural numbers, so this is 1 times 2. Second degree, so the denominator will be 2. For cubic function, you will have constant differences divided by 3. Okay, so that would be sort of the idea. So A is equal to 1. That's the leading coefficient. So we can see now when you activate y is equal to x squared, that forms a parabolic shape, right? And we see that the dots, the green dots, perfectly align with the pattern here. So this confirms that the points here from column 1 and 2 do describe the second degree function parabolic shape. So we have the lowest point here, which is the vertex, and coincidentally this is also the x and y intercept at the same time. And then the shape is defined by the value of a, which is positive 1. So parabola opens up, and there's axis of symmetry, which is lined up with the y-axis. So that's sort of the most basic parabolic function or second degree or quadratic function that we have in front of us. So let's move on and consider the following example. So y is equal to x squared plus x plus 1. If you're already familiar with quadratic formula from other videos, that's fine. Then we utilize the quadratic formula to find the coordinates of the vertex, because we find the average if there is a real or non-real values of x-intercepts. Then either way, the vertex would be found right in between those x-intercepts. You find the average by adding them together and divide by 2. So, but in order for you to identify if there is an x-intercept or not, you use the quadratic formula to see if there are the real roots, so that it is equivalent with x-intercept. Now, the important sort of refreshing your memory, the discriminant condition that or requirements that determines whether you have x-intercept or not. In this particular question, b squared minus 4ac, when you identify a and b and c coefficient, plug into the formula, you get a negative entry, which means that quadratic function has no x-intercept, right? So now if there is no x-intercept, still the rule for finding the vertex location will be the sum of the first would-be root or the second would-be root. So this would not be considered as a real number, would be imaginary number, but by adding negative b over 2a and another negative b over 2a divided by 2, you get negative b over 2a, which will be shown right here. It is already given to you. So this is how you find the vertex, and the y coordinate is found by plugging in that x value back into the equation. So this is the parabola that opens up. The coordinates of the vertex is given by finding the value of x first and then the value of y. The value of the axis of symmetry is coinciding with the x coordinates of the vertex. That's an important key. This parabola opens up. The vertex is the lowest point, so this is the local minimum of the function, and the y-intercept is directly found from that quadratic standard form equation. So when we have that standard form in front of us, we already know what is the direction of the opening because of the a value, and we already know what is the y-intercept. We may not know whether there are x-intercepts or not, and then to find axis of symmetry, which is indirectly related to the location of the vertex, we can use that formula for negative b over 2a to find the location of axis of symmetry. And once we get it, we can find the y coordinates of that point to establish the location of the vertex. So hopefully that makes sense. Let's move on to the next example. In this example right here, you have positive a value. Again, b is provided as 2 and c is equal to 1. So we know the y-intercept does exist. To find quickly coordinates of the vertex, we go negative b over 2a to that formula. Do the calculations, we get negative 1. And to find the y coordinates, you use that number, put back into the formula, x squared plus 2x plus 1, and we get 0. So what is the meaning of that? That is to show you that x-intercept and vertex coincide at one location. So this is the case where the discriminant, if you're familiar with quadratic function, must be 0 in order for it to happen. The direction of the opening is still governed by the value of a, and the y-intercept is directly taken from the formula. So this is at 1, right? So the axis of symmetry coincide with the vertex location. So the equation of that will be x is equal to negative 1 or x plus 1 is equal to 0 in standard form, like you have here. That is the equation. And this is also another form of that same equation. Please remember, this notation x is equal to negative 1 can mean two things in the context of quadratics. It could represent the value of x where the function is equal to 0, which is the x-intercept. It represents the x coordinates of the vertex, and also it represents the equation of axis of symmetry. Very, very important. So the next example, where we have negative a in front of us, right? Coefficient, leading coefficient is negative, so we kind of understand the parabola would open down, and then we have negative b and 3. So the value of c, y-intercept easy. Direction of the opening also is given because of the value of a and being negative. In this case, when we find a vertex location, you still do negative b over 2a method. You find a value of x is equal to negative 3 over 4, plug into the equation of the quadratic function to get the value of y. So we have the coordinates of the vertex. The axis of symmetry is coinciding directly with that x coordinates of the vertex. So this is one equation. You can say equation of the axis of symmetry is x is equal to negative 3 over 4. It's a vertical line. Or if you choose to use standard equation of a line, so you would multiply both sides by 4, move the negative 3 over, so that you get 4x plus 3 is equal to 0. The vertex is the highest point on the graph in this case when parabola opens down. So this is the maximum point. Now, if you were to find x-intercepts, in this case, this function formula cannot be factored. So we would be using quadratic formula to find quickly x-intercept for this function. If you're not familiar, there's another video, so don't stress about it. You can just watch and apply and learn very quickly. So quadratic formula allows us to find the location of x-intercept. Desmos shows the decimal number. When you use mathematical formula, you expect it to get the exact with square root notation. So that is exactly pinpointing the positive value or negative, or both positive, both negative. It doesn't matter. So decimals are useful when you're working with word problems. We'll be showing you a video about that as well. But so far, hopefully you understand what standard equation for quadratic function provides immediately. It gives you the location of the y-intercept, the direction of the opening, so you can identify whether the vertex will be a maximum or a minimum value for that particular case. And standard formula allows you to identify the coefficients A, B, and C so that you can find the location of the vertex, at least the x coordinates first, then you find the y, and then you have every critical point for that function to get. In terms of x-intercept, you would have to use the discriminant first. You would calculate quickly, okay, it's greater than 0, so I have a beautiful situation where that shows 2 possible x-intercept. So practice question is always necessary for us to learn. So learning means application, immediate application after the quick review. So thanks for watching. We'll see you again. Bye for now.